What's up guys, this is Massey. Welcome to another video. In this video I want to show you how to add and subtract matrices. In order to add or subtract matrices, we need to have matrices in the same size or same dimension. Dimension is basically shows the number of rows and number of columns of a matrix. For example, here we have the first example. We have 1 row and we have 4 columns. So the matrix is 1 by 4. And the other matrix is also 1 by 4. So since we have the same dimension, we can add these two matrices by adding their elements. So 4 and negative 6 is going to be negative 2. Negative 2 and positive 2 is going to be 0. Negative 3 and 4 is going to be 1. And 5 and 4 is going to be 9. So basically we need to check if the dimensions are the same, and after that we just add or subtract the elements. Next one, we have subtraction. The size of this matrix is 1, 2, 3 by 1. 3 by 1 means that number of rows are 3 and we have only 1 column. Same thing in here, that's 3 by 1. So the answer is going to be 3 by 1 as well. So negative 5 minus 6 is going to be negative 11. 3 minus negative 5 is going to be 3 plus 5, which is 8. 6 minus 2 is going to be 4. So that's going to be the answer. Next one, the number of rows, 1, 2, 3 by 2, because we have 2 columns. And here is 3 by 2 as well. So the answer is supposed to be 3 by 2 as well. 1 plus negative 1, 0. 2 plus negative 2, 0. 5 plus negative 3, 2. Negative 2 plus 3, 1. 3 plus 1, 4. 0 plus negative 2, negative 2. Next one. 2 plus negative 1, 1. 1 plus 0, 1. Negative 4 plus negative 2, negative 6. 3 plus 2 is going to be 5. And the dimension of each of them is 2 by 2, because the number of rows is 2 and number of columns 2 as well. Next example. This matrix minus this matrix. We have 1 by 4 here and 1 by 4 here. So we can subtract them. 0 minus negative 4 is going to be positive 4. 3 minus negative 3 is going to be 3 plus 3, 6. 5 minus 0 is going to be 5. And 2 minus 1 is going to be 1. So that is going to be the answer to this question. Next one. We have 3 by 2 and 3 by 2 as well. So when you add them, it's supposed to be 3 by 2, 2. Negative 6 plus 1, negative 5. Negative 2 plus 6, positive 4. 1 plus 3, 4. 3 plus 6, 9. 4 plus 5, 9. 0 plus 6, 6. Then next example, we have 2 rows, 4 columns, so 2 by 4. Here we have 2 by 4 as well, so we can add them, and the answer is going to be 2 by 4. 1 plus negative 5, negative 4. 2 plus 2, 4. Negative 3 plus 3, 0. 0 plus 1, 1. Negative 2 plus 0, negative 2. 5 plus negative 2, 3. Negative 2 plus negative 1, negative 3. 1 plus 1 is going to be 2. And here we have 3 matrices, and 3 by 3, 3 by 3, 3 by 3. So 1 plus 0 plus 2 is going to be 3. 0 plus negative 1 plus 3 is going to be 2. 2 plus 0 plus 1 is going to be 3. 0 plus negative 2 plus negative 2. 2 plus 0 plus 0 is going to be 2. 3 plus 3, 6. Minus 3 is going to be 3. 1 plus 0 plus 1 is going to be 2. 0 plus 1 plus 1 is going to be 2. And 0 plus 2 plus negative 1 is going to be positive 1. So that's going to be the answer, and it makes sense because that's 3 by 3. This one is 3 by 3. And this one is also 3 by 3. So the answer is also 3 by 3. Now in this example, we have this matrix. That's 2 by 2. 1, negative 3, 2, and 4. Find matrix B in such a way that A plus B is 0. So I'm going to say A is 1, negative 3, 2, 4. B is supposed to be has the same dimension or same size in order to be able to add them. And the elements, I'm going to call it B11, B12, B21, and B22. The first number shows the number of row, and the second one is going to be the column. So 111 means row, first row and first column. So when you add them, 1 plus B11 supposed to be 0. Negative 3 plus B12 supposed to be 0. 2 plus B21 supposed to be 0. 4 plus B22 is also supposed to be 0. So B11 is negative 1. B12 is positive 3. B21 is negative 2. B22 is negative 4. So it's going to be negative 1, 3, negative 2, negative 4. So that's going to be the matrix B. Next example. It says find x and y if A is x plus 2y, 3x minus 4y, and B is negative 1 and negative 7, and A and B are equal. So what are the dimensions of these two matrices? This one is 2 by 1, 2 by 1. So 2 rows, 1 column. And these are supposed to be the equal matrices. It means that all elements must be the same. It means that this element has to be equal to this, and this element has to be equal to the second number. So x plus 2y equals to negative 1. 3x minus 4y equals to negative 7. So basically we need to solve this system of linear equation. I'm going to use substitution method from equation 1 and move 2y to the right hand side so it becomes negative, and then sub it in the second equation. So instead of x, I will write negative 1, negative 2y minus 2y equals to negative 7. That will be negative 3 minus 6y minus 2y equals to negative 7. So that's going to be negative 8y, negative 7 plus 3 equals to negative 4. So y will be negative 4 over negative 8, which is going to be 1 over 2. So y is 1 over 2, and x becomes negative 1 minus 2y, which is negative 1 minus 2 times 1 over 2. That's going to be negative 1 minus 2 over 2, which is negative 1, and that's negative 2. So we can say x is negative 2 and y is 1 over 2. Now, this example, we have two matrices. The dimension here is 2 by 3 and here is 2 by 3. And when you add them, the answer has to be 2 by 3 as well. As you see here, the second matrix, all the elements on the second matrix is 0. And this type of matrix, which has all 0 elements, is called 0 matrix. Any matrix plus 0 matrix on the same dimension is going to give you the same answer, because 2 plus 0 is going to be 2. Something like negative 4 plus 0 is going to be negative 4. So the answer is 2, 1, 3, 1, negative 4, and 0. That's the answer. Next one, we have 2 by 2 matrix plus 2 by 2 matrix. As you see here in this matrix, the diagonal of a matrix has 1 and other elements are 0. These kind of matrices are called identity matrix. in order to have identity matrix, we need to have square matrix first. And we need to have the elements on the diagonal of the matrix to be 1, and the other elements has to be 0. And then if matrix is 2 by 2, we call it I2. If it's 3 by 3, we call it I3, and so on. So now the answer is going to be 2 by 2 as well. So 4 plus 1, 5. 1 plus 0, 1. Negative 3 plus 0, negative 3. 2 plus 1, 3. That's going to be the answer. Next one. This plus this one. What is the dimension here? 2 by 3. And here is 2 by 2. So since they are having different dimension, we're going to say that's not possible to add or subtract. Next one. That's 2 by 2. And here we have 2 by 1. Are we able to subtract or add them? No, it's not possible, because they have different dimensions. Now the last example, if A is 2 by 2, like this, and B is another matrix, 2 by 2, find 5A minus 2B. 5A minus 2B is going to be 5 times 7, 3, negative 4, negative 1, minus 2 times 9, 6, 3, 10. So when you multiply it by a scalar, we need to multiply all the elements. 5 times 7, 35. 3 times 5, 15. 5 times negative 4, negative 20. 5 times negative 1, negative 5. Minus 2 times 9, 18. 2 times 6, 12. 2 times 3, 6. 2 times 10 is 20. 35 minus 18 is going to be 17. 15 minus 12 is 3. Negative 20 minus 6 is negative 26. Negative 5 minus 20 is going to be negative 21. So basically, that's how we solve these kind of examples. I hope you enjoyed this video. Please leave me a comment if you have any question. Please don't forget to subscribe this channel. You can have access to many other videos regarding matrices and other topics in algebra, calculus, chemistry, and physics. Thank you for watching and have a great day.